Cool. First, I just want to say thank you to Lee for doing such a great job over the last couple of days as our MC. I think we should all give him a big round of applause for the job he's done. So I'm Tom. I work on GraphQL in the core services team at Twitter, where I've been for about 4 years. Now, already you might have noticed my accent. I work in London, and to be honest, I get a lot of trouble at the American border because TSA agents don't understand me when I say Twitter. So a quick translation for you. For the purposes of this talk, Twitter equals Twitter. Because it turns out the T's are important. So just for the rest of the talk, because I'm going to say Twitter quite a lot. Thanks for that. So now, something just quickly, kind of serious business. I realize in speaking at this conference, I am the next in a large group of men, often white, who have spoken today and yesterday. And I want to acknowledge and thank the conference team for all their work trying to fix this, or trying to address this. But it's a community problem, and I hope we can all work together to make sure that the community is as diverse as the ideas that have been discussed over the last 2 days. Okay, so I have 50-ish slides, 25 minutes, although I am last, so I could keep you all night. Let's go. So at the conference, we've heard about a huge range of amazing things that people are doing with GraphQL, as well as practical advice on how to make the technology work in your particular situation. So in this talk, I'm not going to blow your mind with incredible new applications of GraphQL, because you've seen enough of those already. Instead, I'll talk about the specific challenges of GraphQL at Twitter, and I'll give you a sense of the choices we've made. I'll also show you how we've implemented subscriptions, and then look ahead a bit at how we plan to sustainably grow and develop our GraphQL API into the future. First, some interactivity with a quick survey. So hands up if you consider yourself a back-end or server engineer. Okay, cool. And what about front-end or client-side engineer? Oh, cool. And what about like full stack? There's going to be a few people who already put their hands up. Okay, so hands up if you're using GraphQL in any way, as part of a side project, some experiment you're doing, or at work. Cool, but it's not everyone, and that's really exciting. Now keep your hand up, well, I guess they've gone down already, but if you're using GraphQL at work in production. Interesting. So maybe people who didn't put their hands up yet, go talk to those people who just put their hands up, find out a bit more about what you can do. And lastly, hands up if you're using GraphQL subscriptions in production. Cool, okay, interesting. Thanks a lot for that, it's really interesting. So this talk, as I said, will broadly cover 3 areas. The first section is about how the Twitter GraphQL API fits into the large existing ecosystem of microservices at Twitter. Then we'll talk about our subscriptions architecture, which might make an interesting comparison to what you just heard from Rodrigo about their live subscriptions architecture, and from Rob about Facebook subscriptions architecture. And lastly, we'll look at our plan for GraphQL in the long term. So let's start with the Twitter GraphQL API. So Twitter has been experimenting with GraphQL for over 2 years, and it's only really in the last year that we've started to drive adoption in Twitter Lite, Android, iOS, and TweetDeck clients. I used to work on TweetDeck, so that's why it was first. So if you've used any of these, then you probably have used Twitter GraphQL in some small way, because it's not at 100% yet, but we're working on it. Twitter is famously a microservices company. There's a service for everything, and there's often multiple new services for any new feature we build. It's hard to be sure exactly how many production services there are. I know that sounds a bit strange, but things are coming up and going down all the time, and it's sometimes not clear, which services are deprecated and which ones are new. But I counted the number of configuration files for deployments in our mono repo, and I found over 2,000. And remember, each of these circles on the screen is actually a cluster of instances of the same service, sized according to traffic requirements. So we've got a lot going on. Most of these services fit into one of a couple of types. Wow, this is frozen. So the first kind is HTTP services. Wow, I've messed up my slides somehow. This is pretty cool. Okay, the first kind of service is an HTTP service. They receive HTTP requests from all of you on your phones, on the web, on Apple TV, or wherever you're using Twitter. Each API service tends to be responsible for handling requests to a few API endpoints, rendering JSON responses, and making calls to the next layer, thrift services, which will come up at some point. Wow, oh, look at that transition speed. Oh my goodness. Thrift services, cool, thank you Google Slides, loving it. Thrift is a remote procedure call system that's used extensively at Twitter, Facebook, and many other companies. Each of these services exposes an asynchronous typed interface. That means almost all communication between Twitter microservices is already uses types. They're not GraphQL types, but they are types. By the way, if you're working on a new microservice architecture, take a look at RPC technologies like Thrift because they are pretty beneficial in a lot of ways. And like all good ideas, this was invented in the 60s, and you have 50 years worth of work and production experience to rely on. Whoa, what's going on with the slides? I hope not all the transitions are like this, because that would be frustrating. Okay. Here's an example Thrift service description that simply multiplies two numbers. You can see that it's just an interface, takes an A and a B and would multiply them. And from this interface, you can code gen servers and clients to implement the interface. And by the way, this is hopefully the only Java you've seen at this whole conference. I'm not even sorry that I made you look at Java. So GraphQL fits into this picture as an HTTP and Thrift service alongside the others. It uses a range of data sources, including existing HTTP endpoints and other Thrift services. This is pretty similar to the gateway pattern that we've heard a lot about over the last couple of days. And remember, communication between all our microservices is already typed using Thrift. And that sounds a lot like some of the GraphQL native patterns that we've heard about as well. Turns out the GraphQL community isn't the first to find service-to-service type systems useful. And because we're a Scala shop, we're using the fantastic Sangria library. And I want to give a big shout out to Oleg, who couldn't be here today, for his incredible work on this project. Thank you, Oleg, and thank you to the wider Sangria community. In fact, I would just like to show some love to all the open source maintainers in the GraphQL community with a big round of applause. So let's dive into some of the challenges launching GraphQL at Twitter. To start with, we're going to talk about monitoring. And by the way, shout out to Drew for covering this earlier in his lightning talk. I was just watching it going, I don't need to say any of the things that are in my talk. So Twitter engineers are responsible for the on-call monitoring and alerting of the services they build. Most of the time, API services are monitored primarily using a percentage success rate based on the number of HTTP 5xx responses you generate. In most HTTP services, serious errors result in a 500 or a 503, which is really easily detectable. However, GraphQL is capable of representing partial success and shouldn't blow up just because one part of the request failed. This makes tracking success rate a little bit difficult. GraphQL will nearly always succeed with a 200, even if it didn't manage to fetch any data. So instead, we track exceptions per query. For every GraphQL query, we track the number of exceptions generated. Aggregated over a minute, we should see fewer than 1 or 2 exceptions per several thousand queries. That then becomes our success rate metric, and we can build dashboards and alerts that page engineers if the exceptions per query number gets too high. We also use GraphQL-specific defenses to protect the API. Imagine a pathological query case, followers of followers of followers of followers. We have 2 defenses, complexity and depth. First, we measure query complexity. We assign a score or a cost and work out the total cost of the query. So if fetching 10 follower IDs costs 10 query points, and fetching a user's data costs 10 query points, then fetching your top 10 followers would cost you 110. This is the complexity of the query, and we can measure it before the query is executed, and that's really important. By choosing a maximum complexity, we can reject any queries that would be too costly for our backend. We can also defend against malicious queries using query depth measurement. This is simply a query tree height measurement. So for example, we could choose that if you go more than 15 or 20 followers deep, your query is rejected. It's a pretty blunt tool, but it can be useful. But more importantly, we don't allow arbitrary queries to be run in production. All queries must have been submitted, validated, and stored in exchange for an ID before they can be used by a client in production. We call these stored operations, although, as you've heard, they're also known as persisted queries in the community. This restriction means attackers can't probe our GraphQL API or run introspection queries against it to find out what data is available. Stored operations were around for day 1 of Twitter GraphQL because we were fairly sure that as soon as a new Twitter API was public knowledge, we'd get people sniffing at it to find vulnerabilities. Lastly on this topic, I've seen a lot of discussion in the community about how to handle authentication and authorization. So here's how we do it. And to be honest, it's a lot like Tony's talk from earlier, so thank you, Tony, for again covering half of my slides. For returning to this diagram, I want to introduce you to TFE, transition time. Oh, that one worked, amazing. TFE, Twitter front end. I was going to do a robot dance to distract you, but I imagine TFE as a layer between the outside world and all of our services inside Twitter. Technically, it functions as a reverse proxy, API gateway, and router. A large part of TFE's job is to authenticate incoming requests. We support a few types of authentication, and it's impractical for each underlying service to support every type. So instead, we use one standard authentication scheme between services. Let's imagine a request to apitwitter.com that's authenticated using a cookie header. Once the request is passed through TFE, the original authentication scheme is normalized into a bundle that we call Twitter identity assertion. Validating a cookie is fairly involved, so that work is done in TFE. TFE then generates a bundle of these identity assertion headers and passes them on to the service that will serve the request, and in our case, that's GraphQL. GraphQL then just propagates this bundle through to other services. Nobody has to worry about the messy details of how to authenticate the original incoming request. Instead, we can just do integrity checks on the signature to verify that authentication happened, it was valid, and that nobody has messed with it since. Our GraphQL layer has no opinion about authorization either. Each of the underlying services is responsible for it. And again, thanks to Tony for explaining this better than I can. Next, I want to talk about how we have built support for GraphQL subscriptions at Twitter. And I have to thank Rob for setting me up so well for this part of the talk, because the building blocks I will be talking about are very similar to his. And that means I can move really fast because you already understand it already. I also want to thank Rob for some in-depth discussion at GraphQL Europe that helped shape and validate our approach to this problem. So at React Europe a few years ago, Lainey described GraphQL subscriptions like this. I really like it, and I'm going to structure the discussion of subscriptions around it. Clients subscribe to an event occurring in the backend with a GraphQL query and receive payloads. Those payloads represent the result of running the query document against an event. Our subscription system divides the functionality in a similar way to this quotation: events, queries, and payloads. We've worked hard to define clear boundaries between each, and this allows us to work on each component independently and allows each part of the system to hide some of the complexity of the others in their implementation. So first, let's talk about events. Twitter already has an extensive pub subsystem with hundreds of thousands of different kinds of events flowing through it. It's called Event Bus, and with GraphQL subscriptions, we wanted to give clients access to this rich stream of data. Event Bus is a distributed queue system. Event producers are services that publish events to Event Bus, and subscribers are services that subscribe to Event Bus in order to receive events. To expose this data to GraphQL, we built a subscription service that subscribes to Event Bus streams. This service is separate from the GraphQL API. It's stateful, and it scales very differently to the GraphQL API, and that's why we separated it. So we have a service that's picking up events from Event Bus. Next, we need to hook those events up to queries. This is what our GraphQL API is good at. And in our subscriptions design, we extended the GraphQL API to execute GraphQL queries against an event that's supplied as part of the request. That means that it receives both a query and an event and uses the event as the basis for query execution. This is actually a Thrift interface, like the one I mentioned earlier on, meaning we're using GraphQL over Thrift as well as HTTP. This JSON bundle on the screen is an example of something the API might receive. It will run the query against the event from the point of view of the supplied user. In this way, we keep the GraphQL API solely concerned with executing GraphQL queries. And because it's stateless, it's very easy to scale horizontally. So when an event arrives on an Event Bus stream, we call out to the GraphQL API service for execution. Whoa. At this point, we're picking up events from Event Bus and executing them using the GraphQL API. Pro tip for giving talks: don't edit your slides just before you're about to go on stage, because you'll mess up transitions. Next, we have to deliver the resulting payloads. Streamed event delivery at scale is a very hard problem, particularly taking into account multiple data centers and, more generally, computers. In choosing how we delivered subscription results to clients, I knew putting that emoji on screen was a bad idea because it makes me laugh, and it's not a good thing. In choosing how we delivered subscription results to clients, it was important that we didn't try to reinvent the wheel, and we looked for existing solutions to the problem. So with that in mind, we chose to build event delivery for GraphQL subscriptions on top of an existing Twitter technology called Live Pipeline. Live Pipeline is a pub subsystem over streaming HTTP connections. If you've ever seen the engagement counts in a tweet change or typing indicators in your DMs, that's powered by Live Pipeline. Because this system is proven in production, we decided it was ripe for use for delivering the results of GraphQL subscription queries to our clients. In the Live Pipeline model, clients listen for events on a particular topic, and event-producing systems, like those handling tweet engagements, can push events onto a topic by publishing them to Live Pipeline. The event is then delivered to all clients subscribed using the event's topic. To deliver GraphQL subscription payloads, we use a unique Live Pipeline topic per GraphQL subscription. We combine and hash a bunch of data about the subscription to create a Live Pipeline topic, and then inform the client of that topic so it can subscribe using Live Pipeline. When a client initiates a GraphQL subscription query, we return a status message containing a Live Pipeline topic as part of a GraphQL union type field at the root of the subscription. The client then subscribes to this topic with Live Pipeline in order to receive subscription payloads. So the query on your left is actually made to our GraphQL API, returns the topic, and then that is used to connect to Live Pipeline. The client then subscribes to this topic like this and receives the result of the query. And you can see that this time we have the tweet type of the union at the root of the result. And in this way, we kept to the spec where the responses were always of the same type and we didn't have to do any out-of-band topic communication. So putting it all together, I think this is my favorite slide in the whole talk. The client makes a subscription query to the GraphQL API. The API may contact an event producer to tell it that there's a new subscriber. It will then return a Live Pipeline topic, and hopefully that's not behind my face. It totally is. I tried to move it up. Sorry, everyone. Which the client then uses for a subscription with Live Pipeline. Once the event producer starts making events, the subscription service will pick them up and execute the original query using the API. After the API has done its job, the payload is published to the client through Live Pipeline. Of course, there's much more to talk about here, but I wanted to give you a quick overview of our system. The system is built to deliver thousands of events per second to thousands of connected clients. I'm looking forward to coming back here in the future to tell you about how it has developed and what we learn with it in production. Lastly, I wanted to touch briefly on our vision for the future of GraphQL at Twitter. One of our main goals was to help our teams build great products and features more quickly and more easily. As part of this, we're working to make it easy for new data to be made available through GraphQL without anyone manually editing schema code. The technology we're using to power this at Twitter is called Strato, and I want to tell you a bit about it. First, though, a caveat. Strato is not open source and is tied very closely to Twitter, so it's not something we'll be making open source. It's a technology, it's something we have available inside Twitter, and it's very exciting and interesting, and it also maps closely to some other ideas that we've heard at the conference, so I thought it was interesting to tell you about. Strato is a kind of virtual database. A virtual database, also called a federated database, brings together multiple data sources so they can be queried and mutated uniformly. Now that sounds kind of like GraphQL, right? Philosophically, Strato and GraphQL are very similar. Strato has many of the same benefits without the specific focus on building products, or building client applications, actually. Strato has existed at Twitter for a lot longer than GraphQL, and it's the layer we're using to power our GraphQL API. It integrates tightly with our existing Thrift services, and in combination with GraphQL gives us end-to-end types, sometimes from the database all the way to the client. This approach has a ton of power, and we could give whole talks about it. For example, our Strato team has made it possible to add data to their catalog with a simple config file and made deploys automatic. This gives our engineers a huge amount of power and flexibility by removing the need for coordination with other teams. This is an example Strato column that would store the birthdays of Twitter users in a database. The details aren't really important, but it's just config, and that's cool. At Twitter, we've built Strato-powered GraphQL, which allows data in the Strato catalog to automatically appear in the GraphQL schema with a simple config change. So today, I've talked about Twitter's GraphQL API, how we designed our GraphQL subscription system to work at Twitter scale, and our vision for the future of GraphQL at Twitter. It was a super quick overview of some of the choices we've made in building GraphQL, and I hope it helps inform decisions you make as you explore this technology yourselves. I'd like to finish with a discussion, though, of why I think GraphQL is exciting. In the big picture, I see GraphQL as an enabling technology. That means it can drive radical change in the capabilities of a user or culture. We all recognize this in the huge productivity leaps available through GraphQL, and it's kind of the reason we're all here. Enabling technologies also lead to rapid development of subsequent derivative technologies, often in diverse fields. Tools like GraphQL and everything Apollo does demonstrates this, but I'm sure we'll see a huge range of other things in the future, and I really encourage everyone to think outside of the just building mobile apps and websites and think about applications for GraphQL in other areas. In this way, I think GraphQL expands on Stuart Kauffman's idea of the adjacent possible, meaning that GraphQL is so radically different to what we do now that it opens up whole new avenues of exploration that were previously closed to us. The present we have of REST APIs, endpoints, HTTP verbs, and query parameters is one possible permutation of the ways our clients can fetch data. There are others available, and we owe it to ourselves and our users to explore them. Now, that's not to say there aren't problems with GraphQL. It's not done. It's not a perfect technology by any means, and the GraphQL community has work to do on real issues. As with all technology, it's trade-offs all the way down. Please come talk to me or the other Twitter folk who are sat a few rows back if you'd like to hear more. We'd be happy to tell you more about what we do and how it's going. And I think you should probably follow me on Twitter. Thanks very much.